Welcome back to Great Course Mathematics, Unit 3, Number Patterns, Sequences, and Series. So, today we're going to be looking at patterns, rules, terms, and sums. So, these are some of the formulas that we're going to be looking into. This is like the finding the nth term in the arithmetic series. Then this is more like a sum to infinity formula for a geometric series. So in this unit, we're gonna look at arithmetic. We're gonna look at quadratic as well. Quadratic arithmetic. Let me just spell it. And we're gonna look also at the geometric, right? Then we're also gonna look at the sums. So there is finding the nth term. There's also finding the sum of numbers of terms to a certain series. Then we're also gonna find sum to infinity. So this is basically what we're gonna be looking into in this unit. So let's move on. So the unit roadmap, what learners should be able to do by the end of Unit 3. So number 1, they should be able to read the pattern. In other words, they should know the terms, positions, and notations. And they should also identify the type, which is arithmetic, quadratic, or geometric. Then they must find the rule that applies to that certain series. So general term for the nth term. Then they should also be able to calculate terms, so specific terms and positions. So they can say find the fifth position in a certain series. So using a certain formula, you'll be able to do that. Then you can work with sums, which is arithmetic and geometric. Then you must also have a judge convergence, which is like where infinity geometric series end. So this is more like under paper 1 foundation of patterns and series which support functions, finance, calculus, and modeling. So this unit also apply to certain topics within the mathematic fraternity. So let's move on. So we're gonna look into language of sequences. So a sequence is an ordered list. Each item has a position. So in that ordered list, each item has got a position. So let's look at the connotation. So the first term is termed T1, second term T2, nth term is Tn, then n is the position number. So as you can see, when you say T1, it means you are referring to the first position, right? Let's say if we say T5, it means you are referring to the fifth position, right? So A is also the first term. So in other words, T1 is equals to A, right? So looking at the sequence example given below, we can say T1 is equals to 6, T2 is equals to 11, right? So nth term is a term on this series, on this sequence. Then we're gonna look at the position view. So as you can see, it's another way of illustrating it. So we've got n, 1, 2, 3, 4. So it corresponds with 6, 11, 16, 21, as you can see here. So the central task is to move from the list of terms to a rule that works for any n term. So if they say find Tn, then calculate any any term like what you are given. So when you say Tn, is just a placeholder for saying if you are referring to the 10th term, then you say the n is equals to 10, where n is equals to 10, where n is equals to 10. So okay, let me just, n is equals to 10, so it becomes Tn, right? So here we're just familiarizing you with the language of sequences so that you understand, but we're going to go into the arithmetic, geometric, and quadratic expressions, sequences and series, so that you can be able to apply some of these. So here we're just introducing the core notations. So let's move on. So how to diagnose a sequence. So when you are diagnosing a sequence, use differences, ratios before choosing the formula. So in other words, you must be able to know whether is it arithmetic, quadratic, or geometric. So if it's a arithmetic, the first difference is constant. So let's look at this example. So you can see the difference between the numbers in the sequence is 4. So for example, if you take 5 and 9, 5 minus so you say 9 minus 5, 13 minus 9, 17 minus, so 9 minus 5 is 4, 13 minus 9 is 4, 17 minus 13 is 4. So when you see that there is a constant difference, then you know it's arithmetic. Then quadratic, the second difference is constant. What we mean is like when you calculate the first difference, 6 minus 4, okay, minus 2, okay, let me just delete so that I don't, minus 2, you get 4. Then you say 12 minus 6, 12 minus 6, you get 6. Then you say 20 minus 12, 20 minus 12, you get 8. So that's how we get to the first difference. So you can see they are increasing by 2 each. So when you now calculate the second difference, it's now 6 minus 4, you get 2. 8 minus 6 is 2. So because the second difference is constant, then you know it's quadratic sequence. Then geometric sequence, we are looking at a common ratio is constant. So ratio, remember, is the numerator and denominator. So in this case, we take 12 over 3. So 12 over 3, you get 4. Then 48 over 12, 48 over 12, you get 4 again. Then 192 over 48. Let me use my calculator here. 192 divided by 48, you get 4. So when the ratio is constant, then you know it's a geometric. So by the end of this, you should know the diagnostic rule. Do not choose a formula until the pattern type is established. So you have to know whether is it arithmetic, is it quadratic, or is it geometric. So you don't run into calculation without first identifying the pattern. So you use the diagnosis to do that. So arithmetic sequences. So arithmetic sequence, as you have said in the previous slide, a constant difference means the graph of terms value against n is linear, right? So when there is a constant, so it means it's a linear difference. So the formula for the nth term for an arithmetic is a plus n minus 1 in brackets and d. So remember, a is equals to t1, or you can say the first term, right? First term. Then n is the nth term that you want to find. Then D is the difference. So difference between the terms. So for example, you can say T2 minus T1 to get the difference. So let's apply this. So